Hello, and thank you for listening to this episode of the Night Sky Podcast. My name is Billy Newman.
And I'm Marina Hansen.
And we're really happy to be back again this week, one more time, to do a little bit of a rundown of the news and some of the cool observations that we've been making of the night sky. The summer sky right now here in July in the northern hemisphere has been really cool. There's a lot of stuff going on. Or it's just always good observation weather, right? Like we get to go out every night. We get to see more stuff. And the Milky Way is making it up pretty high in the evening sky now. So that's pretty cool to get to go out and see every night. But there's a lot of cool stuff like in the south sky with Sagittarius and Scorpio and the planets that are up. So it's been cool just to go out and kind of see the progression night over night. I've had a lot of fun doing that with you.
Yeah, it's been really fun having some summer weather, some clear skies. Good for observation.
I want to do more like telescope observations with you.
I do too. What I really want to do, I want to do telescope observations, but I also want to get a pair of binoculars.
Oh, yeah.
I think that'd be really fun.
You know, I think that binoculars would be the way to go for us. And I think that would be really cool to get into some of the deep sky objects that we would be able to see with that.
Definitely.
Now, there's a lot of cooler stuff maybe that you can do with a steady telescope. But I've heard of a lot of cool stuff that you can do, really interesting things that you can observe with a good set of binoculars that are sort of set up for astronomy. And there's a few features of those binoculars that are better than others, like the hunting binoculars that you stash in the pickup truck, those 10 by 50s. Those have a narrow angle of view. And you, Marina, know this from doing all the photography stuff that we've been doing, is that angle of view is really important if it's like really wide out, like what we get with a wide angle lens, or if it's like really tight in, like what we get with a compression lens. And so those 10 by 50s are a pretty small angle of view that you get to see, which makes it harder to view the stars and deep sky objects or more interesting features that are in the Milky Way. That's what's really fun, is you get to go out and like point it up at the Milky Way, and you can kind of observe all these really dense clusters of stars that you really aren't able to see otherwise.
Yeah, that's what I was hearing or reading, that the Milky Way is especially cool to look at with binoculars for that reason.
I'd really like to do that. The fall sky is really cool for that. We should get prepped for that and go out for it. But I know like in the fall when it gets really dark, and it gets kind of dark early, but like the beginning of October, like, you know. And I remember my dad and I would go out and we'd take a look at up in Cassiopeia and down to Capella and all those stars in there. And then you try and find like the Andromeda galaxy out there with your binoculars. It's kind of fun. You can kind of do it, but it's cool. You're like, hey, a little wisp, that's a whole other galaxy. That's cool. But it's a lot of fun. There's a lot of stuff like that. I mean, you know, like a cluster of stars or a nebula or something like that. Other things that you kind of make out. And it's pretty fun when you get to find it and you're like, hey, that is different. That's cool. So we should definitely check out some binoculars.
Yeah, I think it would be fun.
I was
Get
hearing
some more observations.
the other best part of that is like we're used to hand holding binoculars, but that makes it really difficult when you're trying to look at stars because everything moves around so much. It's like if you had to hold the telescope up out in front of you and try and make observations of Jupiter, the planets, or whatever it is, that'd be kind of difficult to do. So I guess what they make for you is these tripods that are for binoculars or binocular mounts just for your tripod. Maybe we could try and find that since we already have a good tripod. I don't know. It might be a different thing though.
That's cool though.
It'd be cool, yeah, if we could just steady the binoculars somewhere and then like get a chance to make observations with those. That'd be really cool. I'm sure they have tons of these accessories and stuff on some little telescope site.
Yeah, we should look into some binocular accessories, binocular stuff.
Got to do it. Yeah, it'd be really cool. If you have some binoculars, you could go out tonight. Since it's July, you're probably going to have some good viewing weather. And you could take a look at the moon. It's going to be up in Scorpio tonight. It's really going to be cool. In fact, it will probably be, it'll be really interesting with the naked eye, and you'll be able to observe all of this. But it'd be even cooler with a set of binoculars or a way to kind of zoom in on some of this stuff or to isolate some of it in your field of view. But tonight, like what we were reading, the moon is going to be in Scorpio. And it's going to be really close to Antares, that bright red star. Saturn, I think it's like a little line of those three, right?
I think they're kind of loosely stacked.
It's closer than they're going to be, I think, at any other time for the next month, maybe. maybe, actually, I bet a month from now, it's going to be even more spectacular because we're going to see Saturn, Mars, and Antares in a row there. They're all going to be clustered together. And then this next cycle of the moon, it's going to pass through Scorpio at almost that same spot. So we're going to see all four of those bright objects in a real close cluster in the sky together. And that'll be kind of interesting, because it's a rare thing. It doesn't happen all the time, and it'll only be that time in the cycle of the year that we'll get to see it like that. So it'll be fun.
Yeah, that'll be a good observation to make.
Yeah, it'll be really cool. I think that'll be, I guess, what is it, the 15th now? So it'll be like the week after the Perseid meteor shower. That's coming up too.
Oh, cool. Yeah, that is coming up
Yeah,
real soon.
yeah. So yeah, we should try and look for that. It'll be fun to try and spot out some of that stuff coming up next month. But yeah, for tomorrow, well, for tonight, we have the stuff with the moon. The moon's going to be in Scorpio, I think, tonight, tomorrow night, and then it's going to drift off into Sagittarius, which is going to be really cool. And I think we're going to get a full moon right after that.
I think it's like the 19th.
Yeah. So it's
We get a
just
full moon.
4 more days.
Yeah, really soon.
Yeah, that'll be really
Tuesday,
cool.
I think.
So just a couple more days, we got the full moon. That's probably just past Sagittarius and into Capricorn that we get the full moon for July, which I think it might be the most southern moon of the year.
Oh, really?
If you get a chance, we should check it out. We probably missed it by not judging it against the June moon. And since the June moon would have been so close to the solstice, it may perhaps have been at that time. But what you'll notice is that the location, if you're out in your local area, like for us, we're at the, what is it, like the 48th parallel, 45th parallel.
I'm
It's
not
somewhere
sure.
near there, up from the equator. And that means that throughout the year we see a lot of motion as we kind of rock back and forth in the tilt of the axis that causes the change in the seasons that we have. And so at this time, I think we talked about before, like episode 6 or 7 or something, about the motion of the moon throughout the year. And what we're going to see is that at this time, when our sun is at the solstice, at its furthest north point, when it rises in the morning, and it sets at its furthest north point when it sets in the morning, the moon does opposite of that. And what we see is that during the month that the sun rises at its furthest north point, we see the moon rise at its furthest south point, which is cool.
That is cool. That's interesting how it's opposite like that.
Yeah, and I think it's part of the rotation of the ecliptic line. And that's something we'll have to look at it more and more. It's kind of confusing to understand, but right now, as we look out to the ecliptic, we'd be looking almost due south. Like tonight, when we look into the southern sky, we're going to look at Scorpio and Sagittarius, and those are going to be deep in the south for us, right on the horizon line. In the winter, though, what we notice is that ecliptic line rises much further north, or toward the zenith, toward the highest point in the sky. And so that's when we look, like when we look out to Orion. Orion is below the ecliptic line. Right now, we can't see below the ecliptic line. That's cut off, by Scorpio or so. We can't see further past that to the southern hemisphere stars. But like we're talking about, in the wintertime, we can see Taurus really high in the sky, Gemini almost straight up in the sky, Leo's also really high in the sky, and then it starts to shift. And as we come, as the Earth kind of tilts up for us in the northern hemisphere to give us summer, then we see the ecliptic line go further south on us. It's really interesting how that goes. And we kind of see that rotation wobble throughout our day too. It's really interesting. I don't know how to explain it all, but it's really cool how that happens. But yeah, July, I think, is going to be one of the furthest south points that you're going to see a rise of the full moon. And you can watch it. I guess I would watch it against next month too. You could watch it show up further and further north in relationship to your location on Earth. It'll be cool.
Yeah, that would be cool.
So other stuff that we got going on is the Venus-Mercury conjunction. And I don't know if we talked about this on the last podcast. I think we mentioned in the pre-show, right, is that Venus is going to be coming back up. And like I guess that headline says, is that Mercury is going to be popping back up into the picture too. And I'm really excited to try and observe that with you right now. And this is going to be the tricky thing. Is like, I think you were checking this out, is that it's not going to be up for very much time. It's going to be really
Right.
close to the western horizon. So it's going to be chasing the sun really quickly after sunset.
Yeah, that's right. It'll be a little bit tricky to see, but if you time it right.
Yeah.
And if you have binoculars, or you have binoculars, can help with that too.
Yeah, it definitely would help. And I think The biggest thing is going to be getting yourself into the right location where you can see a clear view of the western horizon.
Right.
That's not too hazy. That's a tough thing, especially in the summer months and especially in these flatter areas. There's a lot of dust that kicks up in the distance, right? Do you notice that?
Yeah.
Like when we were out
There's
in the desert and it's really flat, you can look out 200 miles, but
yeah.
that 200 miles of atmosphere that you're looking through has forest fires in it and has dust in it and other atmospheric things going on in it. And so you get this kind of dirty horizon look. Like when it's really close, that first
Yeah,
20
it's pretty
degrees or so, the
hazy.
horizon line it was hazy. And we get that here too, even with all the mountains and stuff around. But that hazy effect can kind of, I guess, sort of obscure some of those observations that you'd be able to make of those really near the horizon objects that might be a little bit more dim. Now, these really aren't necessarily dim. What we have is Venus showing up right now at a magnitude of negative 3.9, which is really bright, right? That's brighter
Yeah.
than Mars was when we were observing it. So that's going to be probably easier to spot. It'll just be difficult because it's so close to the sun. And that means that we're really going to be in daylight or in twilight at least for a long period of that. So you're not going to be looking into a dark sky when you're trying to find Venus for the first time. So it's just always a little tricky to try and keep an eye on it. You know how that is like when you try and find the first star out at night.
Yeah. You can't quite
It's
make
there.
out
You
where
can you can
yeah.
see it.
You can just barely see it.
Yeah, but it's easy to lose, and then
Yeah.
you can't really come back to it. But there's going to be Venus that's a negative 3.9, and then apparently Mercury is also going to be up, and that's going to be a negative 1.0 right now. So it's going to be it's going to be significantly bright. You should be able to see it. It just depends on how close to that horizon it is. And this period of viewing for Venus is really not going to be the best, perhaps. It'll kind of go by quickly. It's kind of a low pass on our horizon, and then it'll dip back down. Probably even by the first couple weeks of August, it might be too difficult to see.
Oh yeah, that'll be pretty quick.
Yeah,
Just a few weeks of it.
yeah. I mean, it's sort of like a transit of Mercury. You know how we were watching that a couple times this year. It's come up
Right.
and set, but it's really a 3 week period that
Yeah, it's
it's
really
there and then it's
short.
gone.
They move so quickly.
It
It's
really
interesting
the cycle
keeping
does move
track.
faster than you think. Yeah, yeah. It's interesting to watch how fast those things move around. But the cool thing is that if we think of that, that we can see Mercury, we can see Venus. Up from that in Leo, we can see Jupiter, and then further over in Libra, we can see Mars, and then kind of in that area, I guess you can see is Uranus. I think you can see Uranus there. I hope I don't mix that up with Neptune though. I don't know where that is, but Neptune and Pluto are out there too. They're all up right now. All of the planets that we have, all 8 other planets, still including Pluto, you could see if you had the proper equipment, which is probably like pretty high powered telescopes. Pluto's not going to be easy to get, but you can get the others probably. You could probably see all of those things in the evening sky during this period of the summer if you're able to hit Mercury, Venus, Jupiter, Mars, Uranus. Well, I guess Neptune if you can find it, and then looking over to Saturn on the other side.
Right.
It'll be cool. Well, so that's a lot. But, like we talked about in February about the 5 planets being up in the evening or in the morning sky. This is sort of
Right.
this is sort of 6 months later. We see the opposite of that, but we still
And
get another
they
period where we get all 5 visible planets up in the evening sky.
it's cool how it's switched over like that.
Yeah, it is kind of cool. It's cool to watch it, but it's going to be a faster transit of both Mercury and Venus this time around.
Yeah, it'll be pretty quick. We'll
Yeah,
just have three of them again.
yeah. I think
Or two.
it'll be kind of cool. Oh, and then there's that other piece of news where do you remember earlier we made that episode about LIGO, the gravitational wave observatory?
I do remember
It
that.
was really big news at the time. It was the discovery of gravitational waves, which had been predicted by Einstein but never proven before. Most of the astronomy books listed it as a possibility, but they couldn't confirm it. There was no proof for it. There was no observation of anything like it, and it had been believed that we wouldn't really be able to create a tool to measure these types of characteristics of the universe. So it was sort of written off for a while that it'd be either too expensive or too outlandish to try and measure minute changes in gravity over really big distances of space. But the LIGO Observatory I think had two locations, one in Washington, one in like Arkansas or Kentucky, somewhere out in the South. And they were these really long tubes that would kind of measure. It's really complicated. There's this laser that would go back and forth. Since light moves at the speed of light, absolutely. If there's any change in that distance, there would be a change in the measurement of how long it took that light to bounce from one end of this tube to the other end of the tube. And this was considered the way that they would measure these gravitational waves, which would be the actual fluxing or flexing of space time because of gravity. Really interesting, well beyond me as it goes. I think we talked about it a lot in a podcast, maybe around episode 8 or something like that. But yeah, it's really cool. So back in, I think, September of last year, they recorded their first gravitational wave, and then now they're announcing that they accounted for their second gravitational wave, and it's a much more tuned instrument now that they've gone through the first one at categorizing it, and now they're able to detect things that are a little bit less powerful than that first gravitational wave was. So before we were working with like a 26 solar mass black hole and a 30 something solar mass black hole colliding together and then creating this gravitational wave that's rippled across billions of light years of space time, and then this wave is kind of washed through our galaxy. I think they say that last one that I just explained. Do you remember me talking about this, Marina? Like how it flexed the width, the 100,000 light year width of our galaxy, the Milky Way galaxy, by the distance of one thumb across.
Right.
So kind of,
I do remember you saying
how nuts is that?
that.
It's
That's
such a
pretty
big
strange.
space. I don't even know how they account for something like that. But now they've accounted for their second one, and it was less powerful than that. So I think it was like an 8 and a 7 solar mass black hole that collided together. It may have been closer. They say that the signal was stronger, and I think lasted for a longer period of time, so they were able to collect more data about it. But this discovery sort of brings into light some of the, I guess, some of the thoughts about the time, excuse me, the timing of these types of events. How
Mhm.
frequently in the universe is there a collision of two black holes that have been orbiting each other for a long period of time? And it almost looks like every, what is it, 6 months? I don't know, maybe
Yeah, I
less
guess
than
it
that.
seems like it.
Yeah,
We'll
it's
see
kind of funny.
how many more they get.
Yeah, well, it'll be a really interesting field of astronomy and of science for the next 100 years, probably, especially if there's any promising leads with the understanding of cosmology. And I really think that there will be, especially for how much the scientific community has really pushed forward toward using radar telescopes to do a lot of the work that they do. These gravitational wave telescopes are going to be very interesting, especially for studying these really high level science experiments of black holes and of just kind of breaking down the mechanics of the universe at really high mass values. It's very interesting. It's something that I don't understand a lot, but it's really cool that we're able to do it, and that people, as we've been for thousands of years, like we're going to talk about in a second, have been observing the sky and making inferences about how things work. And then now, over so much time, we've gotten to this place where we can have this level of comprehension as to what's going on in the universe. It's really cool.
It's pretty incredible.
It's a really exciting time to learn about astronomy at a low level for us, about learning about sky watching and understanding, at least just more geographically, as we were to talk about the night sky, where things are, what are things, in sort of a light way. It's interesting, or it's just kind of piquing my fascination about the stuff that goes on with space and astronomy. It's really cool.
Yeah, it's been really neat.
Thanks for doing this with me though. It's been a lot of fun to get to talk about a bunch of the astronomy stuff that we're into.
It has. It's been really cool being more involved with it, and just really just the observations that we've been doing have been really nice. Going out more often and really tracking how things are moving. It's really interesting how much you can see of what's happening.
Yeah, I've been thinking the same thing, that since we've been making these observations, it's just been more interesting. It's been really cool, and we're, I guess, more connected with the weekly passing of time that we're seeing, and
It gives me a different perspective of how time is passing.
yeah, yeah, it's cool. You're like, oh, that must have been back in May because that's where Mars. I saw an Instagram
Right.
photo of the southern sky, and it's like, oh, well, Mars was, oh man, Mars was really close to Saturn. It was in Scorpio at that time. That must have been in April because it hadn't gone on retrograde yet. And we've been watching the
Right.
progression of these planets for the period of time, and we can identify these types of characteristics in the evening sky. And I think that's really cool.
It's really cool. I like it a lot. And it makes me think about, I guess, like way back in time,
Yeah.
and like earlier astronomers or just early civilization and the observations that they made. Because I imagine they were even more in tune
Right.
than we
Yeah.
can be.
Imagine how, I mean, and you know this, like how we weren't in tune to those motions weeks ago or months ago, right? We're not really paying attention to it. But once we are, it's obvious, it's clear. You
Right.
identify those things. And I think that's a really interesting perspective that us as modern people were not able to identify these subtle motions of the way that the earth works, the way that the year passes, and sort of the reasons behind why that is. And I think that getting more in tune with that has been really interesting. In fact, I think this is a really great way to bring up what we'd been researching a little bit was this idea of the identity of Venus. You know what I'm talking about? It's interesting.
Yeah.
So, like we were just saying in our news section, how Venus is going to be up right now. We're going to see it in the evening sky. And then there's this idea that ancient people, we have this perspective, maybe they didn't know anything about the sky above them. And there's some thought to that. And I think like now, even if you talk to most people, even in a very literate and smart society, are quite unaware of the motions and the cycles of the things that happen above them, which is fine because it's not germane to business. It's not germane to the bottom line or to raising your family in a lot of ways, like it
Yeah.
maybe would have been back when it was really closely related to you hunting or living or having to just hike through an area that you had nothing to do other than look at the sky. So
Yeah.
maybe that was part of it. But in those cultures that really did start to study astronomy, I really feel, and you see in their works that they really had a good understanding, at least at a base level, of these mechanics or the motions that were going on. But there's this interesting story. Have you heard of this? Well, you definitely heard of this, but the audience might not have heard of this about Hesperus and Phosphorus. This is the other topic we wanted to bring up. I think it's really cool. But like Hesperus and Phosphorus are these other names for Venus.
The morning star and the night star,
Yeah, yeah. The morning star and the evening star
the
that like they
evening
talk
star.
about, right? Like, like all this news that's coming out of Turkey right now. Did I talk to you about that?
Yeah, you did.
Yeah, leaving the politics out of it right now, we were looking at the news and they were spreading their flag open. They're spreading their flag real wide open over all the people as they're celebrating that there isn't a coup or I'm not sure what the what's happening there, but what they're pulling open is this Turkish flag or this Middle Eastern flag, and that is the crescent moon and the evening star and the morning star. That's the representation of the crescent moon and Venus next to each other is what that flag is,
That's really
and
interesting.
that's uh, the the symbol of the Islamic faith. Also, like when we look at the star and the crescent,
Right.
it's Venus and the moon together.
That's so interesting.
It's cool. So that's what they're spreading out right now over their cities and stuff, and hanging it off their buildings, like we were looking at on Facebook Live earlier. And it's kind of interesting that that's still the way that it is. But in ancient Greece, there was this idea that Venus was not just one planet, or well, at least there's this talk of this. And I think we're going to clear this up in our podcast today. Is that if you look up Hesperus and Phosphorus, there's a lot of discussion about how the people in ancient Greece had this idea that Venus wasn't just one object, it wasn't proven to be one object, but that the morning star was a different object, a different thing than the evening star.
Right. So when you see Venus in the morning, that's one thing.
That's
And
one
then when you
object, yeah.
see Venus again in the evening, it's a different object, is the
Yeah.
idea.
Yeah, that was the idea. And I think that's because it's complicated to observe Venus, and it shows up differently at different times of the year. It kind of rises above the horizon line in the evening or for the morning. And so I think that that's kind of part of why that was the case. But really, there's a lot of good evidence that we were reading about that really demonstrates that that's not what was understood. Now, the Greeks may have had an understanding of this, but as it goes, the earlier society of the Babylonians had a much better comprehension of the motion of Venus. And there's a good bit of evidence that we were looking at that there's still circumpolar stars.
And what are circumpolar stars?
Well, so like since we live in the the northwest here, or the northern hemisphere, when we look to the north, let's say we look at Polaris, the North
Right.
Star. That star doesn't set,
Right.
and I think circumpolar means it goes around the pole. So probably every
Oh,
star is
okay.
circumpolar, but I think for this case, what it is that a circumpolar star would be a star that we can see the total rotation of,
That we can observe
that we
the
can observe
rotation of.
without that star setting below the horizon line and then dipping back up out of the horizon line.
Okay.
So I think like what would it be? I think like Capella is our furthest north point for that.
Sure.
And the further north we go, the more things would be circumpolar because we get closer and closer to the pole. I think, well, is that right? Yeah, that would be right because right at the equator, everything would rise flat from the west and set flat to the east without this big arc that it makes around. And so, like we're talking about, since we can look at the North Star or like the Big Dipper and we can see that all the way through the year, we see it make a full circle. So the ancient people would have been aware of the circumpolar rotation also. And that would have been a quick thing to sort of dispute any idea that something transiting from east to west and then setting would be a different object or would somehow be gone. It's because we can see them still. We can see their counterparts, these other stars, going in smaller circles. And we can see just down from that that these others seem to dip below the horizon and then dip back up out of the horizon again in the west later in the year.
Right.
So I guess that was kind of a thinking that the ancient Babylonians were able to observe Polaris and the Big Dipper and those other stars to the north, and they were pretty clear that stars, move from the eastern horizon and set to the western horizon, and there isn't a difference. It's not a different object when it rises versus when it sets. But really, where it comes into play is sort of the mythology of the people. That Hesperus was the name of a god character that was labeled to the identity of the morning star, or excuse me, of the evening star. Hesperus is the evening star. Phosphorus, on the other hand, is the morning star.
And is that also another mythological god character?
Yeah, I think it's another mythological god. It's complicated, and this is a part of Greek mythology that starts to break down for me. You see, there's Greek mythology, and that's sort of translated into Roman mythology, and that's sort of where we get a lot of the names that we have today. So it's kind of confusing because there's Venus that we say, and that was Aphrodite
Right.
in Greek, but we're calling it Hesperus and Phosphorus. So I'm not sure how that comes together. It's
It's a
kind
little
of,
confusing,
yeah,
right?
it's a little confusing, but there's another interesting part of that too, and this I think is where we get Hesperus. I think that's Roman Hesperus. So uh, I think, or no, it's Greek, right? Greek is
I
Hesperus.
think so.
Yeah, okay, that's what it is. Hesperus is Greek, and then in Rome, when they translated it, it was Vesper instead of
Oh.
Hesper. It's Vesper, and Vesper means supper.
Okay.
Yeah,
So
so
like
it was the
the dinner
supper
star.
time star.
Mm,
Yum.
that's cute.
Yeah, Hesperus. Oh, it's dinner time. I think was part of it in a way. There's other mythology that you can Wikipedia if you'd like to, but just talking about the mechanics of the star, I thought it was kind of cool, or like the change of the word over time of Hesperus to Vesper to Venus or some, but and then to um, Hesperus, Vesper, and then supper. Eating some chow, eating some dinner time. So that's kind of a cool, like, interesting way to think about the the rotation of Venus and like the idea that they thought that it was Hesperus and Phosphorus over different periods of time throughout history.
Yeah. So is the conclusion that you reached from the stuff that you read that basically the idea is that it was pretty well understood that it was the same thing and
Yeah,
it was more, I don't know what the right word would be, but
it's
it was more like
it's
storyteller
story and
or
it's language in a simple way. Like think for a second if 2,000 years from now there's another culture that speaks another language that's translated our ideas and our myths and our names for planets into new things and new pieces, they'll be real confused if we say, "Oh, that's Venus." And they have whatever their future language name is for it. That's Venus. But then they hear of some comment or some writing of ours that says that's the morning star and that's the evening star. when those words and that type of grammar isn't used in context for the future language. And it's almost the same type of circumstance that we're working with here, where we're talking about English now, then pulled back to Latin in Rome, and then pulled back to Greek before that. So there's, like we've learned, I guess, from my small study of a couple years of high school Spanish, there's like different conjugations to the way that you speak about things,
Right.
and different, or just slightly different ways that the word comes together. Or maybe one word could mean a whole phrase, "the evening star" or something. It's like a conjugation of that concept versus phosphorus being a conjugation of another concept. So I think it's more of that idea that, like, now we say the evening star, and that's clear that, oh well, yeah, it's the evening, it's a star. Oh, yeah, of course. Oh, the morning star. But we're not identifying those as two
As
separate entities. We just have names for them, given that their characteristics for the evening, or being in the evening, or being in the morning, are
right.
unique to themselves. Yeah. So I think that's kind of the idea behind it, but it's kind of a cool thing. There was, what was the other thought of it? I think when I was looking up Hesperus and Phosphorus stuff, there's really just like a lot of mixed information about it. Wikipedia is not super helpful. There's some cool like anthro astronomy texts about it that I think you can look up too if you want to learn more about ancient Babylonian astronomy and how they sort of worked stuff out at that time, or what they were aware of and what they weren't aware of. But I'd never heard of the Hesperus Phosphorus thing before we started really looking into it, when we started prepping stuff for this podcast way back.
I really
And
hadn't either.
yeah, it's kind of a cool little thing. So I think it's really interesting that Hesperus and Phosphorus were like these two names that were identified in ancient Greece that, talked about just the one object being Venus. I think it's kind of cool that, well, at least cool, like looking into it, sort of having a better understanding of it now. I like that.
It's yeah, it's cool. It's interesting learning about how how people viewed things, or that idea of
Yeah,
they recognized this planet
they did. Yeah.
and they had the
Well,
things that they called
and
it.
similar to like what we were talking about at the beginning of the segment, is that, just over a couple months of us observing something making a motion in the sky, you have a way better contextual understanding of what's happening or where things are. You're not confused tomorrow night when Mars is moving back just a little bit. You've kind of noticed that, or you've
Right.
noticed the progression of the sky. You're seeing what's coming up later or earlier and earlier into the evening, that you're getting stars that seem to be further and further back into the east. And so you're seeing that progression of the year, the movement of the Earth, as it would be later known to be understood. But it's just interesting when you get a little bit better understanding of the rhythm of a year, you're able to make more clear observations about it. And I think that these ancient people were definitely more able to do that than what we're giving them credit for a lot of the time.
I think so too.
Yeah,
I think that they were probably really on top of stuff.
yeah. Even in just the lay understanding, or like the simple, just
I think so
regular
too.
people
Like,
looking at
yeah,
things.
you see it.
Yeah,
You see it every day. So
not.
even if you're not like actively trying to understand or pay attention to it, you notice it.
I
Kind of
definitely
like
agree.
I don't know, like you notice weather. Like
Yeah,
you notice the weather is
yeah. You
different
notice
during
the
the
weather
seasons
change,
of the year
definitely. Yeah, I think
because
similarly you
you're
notice
around it.
the sky, and they did notice the sky. That's why astrology was studied for such a long time,
Yeah.
and because they were watching the motion of the planets. And there's lots of places that did, and lots of places that were aware of that in a really clear way. So I think it's really cool. I'm glad we got to chat about some Hesperus phosphorus stuff.
Yeah, it was really interesting learning about that a little more.
Yeah, I had a good time. So, Marina, what cool observations have we been making? We've been out a couple times this week. We've been checking out a lot of the stuff in the summer sky, and I'm really excited. I think there's a lot of cool stuff that we're going to talk about in this next segment. Some little stars that we can try and find.
Yeah, there's we've been doing a lot of little evenings out now that the weather's been cleared up, and one of my favorite ones to talk about for summer is the summer triangle.
Yeah, it was one of the first
And
things I ever learned.
yeah, and that's a really cool one. It's not a constellation,
Right.
it's an asterism.
Yeah.
And so in 1930, I think it was, the what was it? The International Astronomical
I
Union,
love those guys.
those guys, they defined the 88 constellations that we
Right.
have in our sky. So the sky is broken up into like 88 different regions.
Yeah.
And the idea is that constellations contain all of the stars that exist.
Yeah.
Um, And so a good example of this is a really common one, like Ursa Major is a constellation that contains tons and tons of stars.
Yeah.
And it has the stars that are kind of the the primary ones that are kind of the shape that you make out of it, but it contains a lot of stars.
Yeah. Everything in that region of space, that whole square footage, if you were to think, or cubic space, really, because you think about the depth, everything out from our perspective of Earth out to that, to the end of the universe, is what's contained in that region of space. That's what's contained in that constellation. All the deep sky objects that we associate, like the galaxies. Well, I guess you could kind of appropriate those to another body unique to itself. But when you're classifying its location, you talk about it and where it is in that constellation. And like you're saying, like we look at Ursa Major, like you're talking about, and then we look at the Big Dipper, those bright stars, but there's all those other stars in that space, that region. What's in the Dipper? The milk, right? But all of that, those are all part of Ursa Major, the constellation also. But then there's this asterism, the Big Dipper, or the shape of the bear that we see, or the shape of the scorpion that we see in Scorpio, or the teapot we see in Sagittarius. All these things like kind of work like that. It's
Right.
interesting.
Yeah. So there are constellations, which would be Ursa Major, like we just talked about, and then the Big Dipper, which is an asterism in the constellation
Yeah.
Ursa Major, and the Big Dipper is just the seven stars. I think it's seven stars.
Yeah. Yeah.
It's
I
just
think
the
it's seven.
seven. It's just the seven stars that make up the Big Dipper, but not any of the stars that are in between those stars that are maybe fainter.
Right.
Um, and so that's the difference between an asterism and a constellation. One of the things about asterisms also, and this is true specifically for the summer triangle,
Hmm.
is that the stars within the asterism can come from different constellations. So in Ursa Major, the Big Dipper is just stars within Ursa Major,
Right. Yeah.
but the asterism, the summer triangle, has three stars, which are from three separate constellations. So um, the the brightest star, or I should tell you the three stars that are in the summer triangle, and not get ahead of myself. So there's Vega,
Yeah.
Altair, and Deneb, and Vega is the brightest star, and
Vega's
Altair,
really bright.
Vega
Yeah.
is very bright, and then there's Altair, which is also a really bright star,
Yeah.
and that's the second brightest in the summer triangle, and then the third brightest is Deneb, and
They're really easy to find.
they are
That's what I've always
very
really
easy to
appreciated.
find.
And they're easy to get to early in the evening.
Yeah, the cool thing, so Vega actually is my favorite star
Ooh.
because it helped me find my favorite constellations. So when I was a kid, I was really into Hercules. I was really into like that mythology when I was like
Yeah. Yeah.
5, and my dad would do astronomy stuff with me at
Right.
night. He'd like take me out, would always point out Venus and a couple of the constellations and stuff. But I was really into Hercules, so I would have him help me find the Hercules constellation. But Hercules is kind of hard to see, I would
It is
say,
hard to
if
see.
you're
It's
5 and you don't really know.
it's faint, and
But
especially in our area, it's difficult. It's very
right.
difficult.
And so right below Hercules' foot, if you're looking up at Hercules, it's his left foot. And under his left foot is Vega. And
Yeah.
Vega is in the constellation Lyra, which is my favorite constellation.
Oh yeah.
Lyra is from the word lyre, and lyre
Yeah.
is a harp.
Right.
And I played the harp when I was a little kid. So
Little
I
harp.
thought that was cool that the little harp constellation helped me find the Hercules constellation. So I would always use Vega and
Yeah.
the Lyra, the harp constellation, to find Hercules.
Ooh.
Because it is a really bright star.
Yeah.
They're really bright.
Vega's really bright. Vega's it's like a bright blue color when you
Yeah,
look
it's a
at it
blue white.
versus other things, and that often indicates that it's a main sequence star. We should learn more about this for the first. I'm remembering back to early on when I was first learning about astronomy stuff and about main sequence stars. Our star is like relatively small. Main sequence stars burn hotter And so therefore they burn at higher temperatures, and then they burn at higher radiation levels. That so our sun shows up as yellow, whereas these
Right.
main sequence stars, they show up as white hot, or they show up as like blue hot.
Right.
That's how much more energy they have, how much hotter they are. So that's where we get Sirius as a really bright kind of blue white star. We get Vega as a really bright crisp white blue star. Most stars are main sequence. I think it's why they call it main sequence. It's just sort of the the normal track for the progression of a star throughout time, and they burn up faster, in fact, than our sun does. Since they're it's like gas mileage on a supercar, right? It's not very
Hmm.
good. It's a bigger engine. It's consuming more faster at a higher rate of speed, and so ours is a little four banger star. It's a little easygoing Honda Civic star. So it's got better fuel economy. And that's why it gets to last so much longer before it goes supernova or whatever it might be later on. So it's kind of a cool thing, like about Vega and Altair too, like the other star in that.
Right. Yeah. And Altair is so the things about the summer triangle that's kind of cool is that the stars that it's made up of are the brightest stars of the constellations that it's made from.
Yeah,
So which makes sense of why we'd see it and pick it as an asterism because it's the brightest. But Altair is in the constellation Aquila, I think is how
yeah,
it's pronounced, and
Aquila.
that's the eagle.
Yeah,
And then we have Lyra, which I already mentioned, which was the harp.
yeah,
And then Deneb is the brightest star in the constellation Cygnus.
Cygnus.
Yeah,
Yeah,
Cygnus. And Cygnus is the swan.
yeah. It's like two birds in that section. Is what I remember. It's
Right.
like a little part of it. Yeah, that's cool.
Yeah,
Yeah,
it is
Deneb is really
cool.
cool. It's a very pretty star. And then I think there was another star in Cygnus. It was Satyr or Satyr.
Is it
What's
a
that?
double star?
Am I? Or not Deneb itself, but in the constel. Remember when we were looking at the
In the
constellation
summer triangle constellation or in
of Cygnus?
oh
Yeah,
of
when we're
Cygnus
looking at
specifically?
Cygnus, there's Deneb, the brightest star. The second brightest star in the constellation of Cygnus that we look at in the Milky Way is
Right.
another star called Satyr. I'll point it out to you tonight too.
Oh yeah.
And I think we looked at it a couple summers ago when we were kind of poking around. But yeah, that's another one. I also remember that, if I'm right, I think it was the first. I think the first black hole was discovered in Cygnus. I think
That's
it's
cool.
Cygnus X1, right? There's like a Rush song about it.
I don't know.
Yeah. What was Cygnus X1? Galactic X-ray source. That's what it is. So it could. Well, I don't know. I don't know. It's a galactic X-ray source. Thought
um
to be a black hole. Hey, there you go.
I guess it must have Cygnus probably has some pretty strong stars in it.
Yeah.
I guess
Well,
like or what I was thinking is like Deneb is really far away. Deneb
right.
is really, really far away, but it's very bright. I think
Yeah.
it's well we're gonna talk about stuff
Yeah.
later, but
Distances and stuff like that. More
I
than
think it's like 1,500
1500.
light years
Hugely
away.
far away.
And
And
it's
still super
so
bright.
bright. Yeah.
Yeah.
If you when you are looking up at the summer triangle later, you can look at the three of them and you'll see Vega's brightest. Vega is the brightest, but all
But it's
three of them
close
are
too.
yeah, but
Vega's
all
very
three of them
close.
they're very bright.
Yeah. And it's very interesting
And
when we
yeah,
have that
Vega is
perspective that they're
much
so far.
closer. Yeah, so there's Deneb that is 1,500 light years away,
Yeah.
and then Vega, the brightest one, is only 25 light years away,
Right.
which
It's
is
really
much
close.
closer. So I imagine it's a lot smaller.
Vega, we'd almost consider in our local group, like when we talk about Sirius being eight and a half light years away, up
Right.
to 26 or so. Those are the main sequence stars that are in our neighborhood, as it were. And it's kind of cool. It's cool to talk about in juxtaposition to Deneb being, 1,500 light years away. You think, how much more massive is that star? How much bigger is that? And it's still blue. It's still white hot. It's still, super massive star. And that's really interesting. It's probably like, I don't know, what, 50 to 100 solar masses bigger than ours, which is huge.
That's
It's
pretty
probably
huge.
it's one of the biggest, the biggest and brightest, stars that we see. But that's interesting too, because in that area, right, when we're looking in the summer triangle, it's a really great way to identify sort of the barrier of the Milky Way galaxy that's up above us in the northern hemisphere during the summer months. It's really cool. I did get to see that, especially in dark skies. What you see is the bright points of Vega, Altair, and Deneb in those constellations. And then all through there, between that, what's making up those constellations is the really rich look of the Milky Way galaxy and those dust clouds that you can see as it kind of bands across the sky above us.
Yeah, it's really cool. That's another one of the cool points for the summer triangle is that you can use it to find the Milky Way or to locate the Milky Way.
Yeah.
So if you're looking at the summer triangle, if you're looking east, I think it's if you're looking east towards the summer triangle, you're gonna look up at it, and kind of the top of the triangle is gonna be Vega, the
Yeah.
brightest one, and then down and a little bit to the left of Vega is gonna be Deneb,
Yeah.
and then
Out to the
out
right.
to the right from both of those, and the one that's the furthest away
And just a skosh down.
is Altair. Yeah,
Altair.
just a skosh down.
And
And
Altair's cool. You can identify it in the sky pretty easily because there's two other stars that are pretty close to it, a little bit dimmer, probably second or third magnitude, that are just on either side, up and down from Altair in the middle. And you can kind of find that. It's like, it's not, it doesn't look like Orion's belt, but it's like three tight stars and about that much space
yeah.
across. And that's what's cool about it. So you can go, oh, hey, there's Altair. I can see that. And you kind of recognize it because of the context of the stars around it sometimes.
Yeah, that's pretty cool. Good way to spot it. But yeah, you have Vega, Deneb, and Altair, and then to kind of see where the Milky Way goes through there, it goes pretty much straight through how you'd picture it, but it crosses between Vega and Altair, and then Deneb is in the Milky Way.
Yeah, it
If
probably
you're
like, yeah,
looking
dead
at
center
it.
when you're looking at it, which is
Yeah.
pretty cool. It's interesting when you look at that thick wafer of stars in space that's right there, especially like what we're talking about. If we get like binoculars or good binoculars up,
Right.
we can look at a lot of that cool, dense texture of the Milky Way galaxy there. And then what's interesting too, say you stay up a few hours later than that and you look in that same spot, space is almost empty in that location because the Milky Way, that dense disk that we're looking flat into, is up past us now. And now we'd just be looking out into away from the disk of the galaxy, out into outer space toward all the other galaxies and other things that are much further and more distant and more dim that we don't get to see. Like later, a few months from now, when we're looking out to the south after Scorpio and Sagittarius and all these bright parts of the galactic center move past us, what we're going to see is like Familo. And it's just it's like a second magnitude star. It's the brightest thing in that whole region of sky until we get into those winter constellations again later in the year. So it's a big empty section of the sky that there's not as much to, at least for us as naked eye sky observers, to really get to see in that area, even in the dark sky.
Yeah, it's interesting how it moves around like that.
Yeah, it is pretty interesting. But I was thinking like we talk about, so we have those summer stars,
The summer
or
triangle.
the summer triangle, but there's these other summer stars, right? These other bright ones that are up right now that I figured that we should like run through the names of. We should try and like
Yeah.
have some context of where they are, what you can see. And we did that a little bit in the winter when we were talking about like the winter hexagon. I think talking about the summer triangle is really cool. That's one of the best ones to learn when you're first starting out. I think because it points up with Vega kind of pointing westward. If you were to think of it as an arrow, as it rises, it kind of moves out westward above us. And it's kind of cool to watch. You see, I think Vega is one of the stars that gets real close to the zenith point for us here in the northern hemisphere, just right up above us, like directly up from us at a certain point in the evening. And that's kind of a cool thing. Did you ever watch the movie Contact?
Yeah,
It's
a long
about
time ago.
Yeah, they're going to Vega in that movie.
Oh, right.
Yeah, because it's 26 light years away. It's closer.
That's pretty close.
Yeah, it's cool.
Comparatively.
Yeah, might as well not go to Deneb. But yeah, that was cool. I remember because when I watched the movie when I was a little kid in the 90s, I was like, I know where Vega is. Whoa, it's outside right now. And then everybody else I talked to has never seen Contact and doesn't care where Vega is anyway. I said, well, but it's that. Oh, no, I don't care. I got other stuff to do. No, I want to find it. So the other stars that are up in the sky that I think you guys should definitely get a chance to take a look at least in the northern hemisphere. I'd love to hear from someone in the southern hemisphere about what they're able to observe during the summer sky. There's a lot of stuff. I think it's like all the stuff in like, was it Crux?
Oh, yeah.
And there's a few other constellations. Well, what is it? Is it Centaurus is down there? And that's got a
I
lot
think
in
so.
it, I think, right now. It'd be really cool. I'd love to see that section of the sky. Uh, Someday, Marina, we got to go down to the southern hemisphere in the summertime, see the
Yeah.
stuff that's going on. So right now, I think the furthest westward star that we'd see is Spica, and that's going to be in Virgo. In fact, Virgo is going to be setting soon. That's the constellation that's going to be in the sun during the month of September. And so, yeah, Spica is the brightest star that's in that region there, which is another a bright main sequence star. It's another white star, and that one's really well. It's interesting because as the summer kind of progresses, we start noticing even now, even in mid-July, we really see Spica dropping down to the western horizon pretty quickly after sun sets. You know, it's not really too deep into the night by the point that you're really not able to observe Spica for much longer. Now, and it's always like that on that part of the sky. Well, or at least it seems to be. It seems to be that like the evening kind of sets those celestial bodies quicker than everything else, and it seems like they're gone sooner for you. But its best viewing period is probably in the springtime when it's really coming up through the sky. It's one of the most interesting things during that period. And then just up from that, like what we've seen a handful of times, what we looked at the other night is Arcturus, and Arcturus is in the constellation of Boots or Bootes, I've heard too, which is probably a more real translation to whatever it was before. But I'd always heard Boots. Or maybe I read it when I was a little kid. Boots. I can read that. I think he was like a goat herder, something like that. And yeah, it's a really insignificant little constellation right there. It's like that and two other sort of small stars that make the little shape of whatever it's supposed to be. But really, the only thing that's important in that area is Arcturus. That's the brightest one. And I think that's an orange giant or red giant, kind of like Aldebaran, and like we'll talk about in a second, Antares. Those are like those reddish stars. You kind of look at it tonight when we go out. We'll see that it's got this orange color to it. So it could be like an orange giant, which is what I think it is. And what do we have written down for Arcturus? Fourth
It's
brightest star in the sky and 34 light years away. That's cool. It's kind of in our local group too. The other cool thing about it is if you're able to find Arcturus, you're able to arc over. If you kind of make a little circle shape, you're able to arc over to the Big Dipper,
right.
and that has like the arc of the handle in the Big Dipper is what you're able to see. But it's kind of a nice way to find a couple things in the evening sky in this in the northern hemisphere here.
Yeah, it's a good one to help you find stuff. It's really bright.
Yeah, and Arcturus is a really easy one to find. That's helped us out a couple times. Like figure out where we were. We're like, oh, well,
Oh,
that's
yeah.
Arcturus out there, so that must be east. That's what we were thinking at the time. I remember that was great. So there's Arcturus, and then to the south of that, if we drop back down into the constellation of Scorpio, what we're going to see there is that real bright first magnitude star that's red. It seems bright red versus the context of the stars that are around it. And right now we have Saturn and Mars out there, so it's adding to the interest in that area. And it's a very interesting section of the sky. Scorpio is one of the most clearly represented asterisms in a constellation. You know, it looks like a scorpion. It looks like it has a
Right.
shape to it. Multiple cultures who were separated from each other all identified that object in the sky as a scorpion. Some others identified it as like a big palm tree that was like leaning out over the water, which I think is a fun one. I think a couple others, what was it called? Like Nepa or something, something like that, in like North Africa for a period of time. It was like another name for it, but I think even that was a scorpion, something like that. So yeah, it's kind of a trippy thing. It's weird how different places have different understandings of it. Maybe it was Hawaii that thought it was a palm tree, a little palm tree
That
chilling
makes
out. They
sense.
don't have scorpions. Maybe they do. Ugh, yuck.
Ugh.
I don't know, but I think it was one of those island areas that thought of it as like or like tropical island areas, right?
Hmm.
That's what they have context of. Yeah, it was like little coconuts or something on it. Be cool.
Yeah, that's
But
cute.
the star Antares is the heart of the scorpion is the idea, and it's like a bright red star, and that's a super red giant. It's super far away. I think we're talking about 520 light years away, which is very distant from us. And that real bright red colors come from it being a super giant or, you know, a red giant star. which is really cool to get to observe. And it's cool that it's so bright as it is, but it's always been one of the most identifiable things in the evening sky, at least for the summer months while it's up. And that's what I really dig about Antares. That's one that we've always been out to check out, when we go out to the
Yeah.
evening sky.
Scorpio's one of my favorite constellations.
Yeah, me too.
My constellation.
Little Marina constellation.
November constellation.
Yeah, that's what I always think of it as, is, Scorpio. Being born in November.
Yeah.
You gotta take some pride in
November
oh
kings.
yeah, cool. The constellation associated with me, that one looks like one.
It's pretty cool.
That's great. I'm all in for that.
It's got some cool stars in it.
Yeah, that's what I thought was cool too. And then out, like what we talked about, Vega, Altair, Deneb, those are also really bright stars in the evening sky, kind of toward the west. And then what you'll notice is that past that, like further east of there, as the year progresses, there's not as many bright main sequence stars to observe. So this section of the year in summer is a really great time to get to view a lot of these cool, bright main sequence stars. It's always it's a populated section of the sky.
Yeah.
And that's why it's fun to get out right now and do as much observations as you can during these summer months.
Yeah, this is a great time. It's cool how we get to see so much right now. And it's interesting.
And 3 planets up.
Yeah, and 3 planets.
4 or 5?
For a few weeks, yeah.
for a couple more days, yeah.
But yeah, it's cool. And it's interesting noticing as we change through the seasons that there are parts of the sky that have a lot less that we can observe.
Yeah, it's interesting kind of figuring out how that space sort of works around us. It takes years, right? It takes years of trying to like perceive the sky around you to sort of understand, or at least begin to understand, the motions that we're going throughout the year.
Yeah, it's really interesting. I wonder how many years it takes before you like pretty solidly feel like like before it was figured out, before you already kind of knew the idea.
Kind of can figure it out.
Yeah, I wonder how long or how many years in a row you would need to be to really remember precisely.
It wasn't clearly told to me a lot of the times from my own observations over time. I think by the time I was about 16, I started having a more clear understanding just about a number of times that I was able to see it.
Yeah.
And I was trying to figure it out for a while too. But there's still a lot of nuance that I'm really not clear on. Like what we were talking about of like the moon rising the furthest south that it will. And like, why does it do that versus, just like the motion of the day and where the ecliptic is. Because the sun is still on the ecliptic. It's just sort of how our day moves about throughout the year. And that's a really peculiar part that my little mind doesn't pay enough attention to, at least at this time. So I don't know. It probably takes years and years before you're just like, oh yeah, I'm really used to how the year is at this time. I'm comfortable. It's been that way all my life. You see these cycles again and again. It'd be fun when we're old and we'll think, like, oh, I remember all these cycles. Oh yeah, I remember seeing this sort of stuff.
That'll be really interesting, like 20 years from now.
Well, we'll be so old in 20 years.
Oh my gosh.
Oh my gosh.
Kind of old.
Well, we'll try and put that off for a while. So I think that's about everything that we have to speak about for this extended episode of the Night Sky Podcast. Hopefully we put in some cool extra content in here. I thought we had some cool stories on this one. Talking about Hesperus and Venus being up, the gravitational waves, the cool first magnitude stars that we're able to see, all the cool stuff about the summer triangle above us. That was really fun. That was like the first thing I was learning when I was a kid. It's really pretty. I really dig that stuff. Yeah.
The summer triangle is a great one.
Yeah. It's a good way to kind of get into astronomy. You can remember all those. You can watch them all summer.
Yeah. It's always up, and it is very easy to find. Yeah. You can find Vega.
Oh yeah. It's just straight up in the Northern Hemisphere, at least. It's cool.
Look east.
Yeah. Look east. It's cool. We'll watch it through the year too, and we'll see what it looks like as it kind of wraps back. And we're like, oh, what was that?
Right.
Vega way out to the northwest. Oh, that looks upside down and weird. It's just weird as it kind of evolves through the year. And you're like, oh, that's a shape?
I remember last year having a hard time when it changed.
Right.
Or getting confused. I'd have to spin myself around a few times while I was looking up at the sky.
Yeah, no, I always
line
did too.
where it was.
Yeah, you look out to Altair and you're like, Altair on the horizon? But what? Horizon? It just seems twisted how it goes by. And that's another one of those things about your perspective through the year that you're like, oh, wow, I didn't recognize that it would do that. It's interesting. So it's really cool. it'll be cool to keep an eye out for the next couple weeks. We got a lot of fun stuff coming up too. We got some cool planet observations to make. We've got the Perseids coming up.
Yeah, the
Just a
Perseids
couple weeks. I'm really excited. We should do some stuff in preparation for that. I don't know if we can promote promote for the Perseids. We might have a good year this year. I'm not sure though. We might have a bit of a moon, but I think late at night. See, given like where the moon is tonight, right?
Right.
It will set, and I think we're looking at like the 10th, 9th, 10th, 11th for the Perseid meteor shower in August. So I think the moon's going to be at an earlier phase and then set earlier in the evening. So if we're die hard and we stay up, past midnight, we're really going to get these dark, bright stars and shooting stars that we're able to see out to the northeast when we're looking for the Perseids. So that'll be really cool. We should do a bunch of cool observation prep for that.
Yeah, I think that'll be really cool. I'm always excited for the Perseids every year.
Yeah, it's a fun one. It gets everybody out too. It's worth it.
Yeah, I think that's one that most people, just about everyone's
feels like something's
pretty
going
into, knows about.
I think it's fun. Yeah, it'll be really cool. I'm excited to do all this extra astronomy stuff with you too. Oh, and check out our Facebook page. We just got that set up. It's facebook.com/night sky. Well, what is it? I don't know. It's nightsky.io. You can check it out. Search for us on Facebook and you'll definitely find our page. But yeah, we're ramping it up. I think we're going to be doing just more content, posting these podcasts, maybe posting some video stuff, doing some live streaming if we get that worked out. So it'll be really fun. And we really appreciate everyone taking a long time for this one and getting through these podcasts, maybe hopefully learning a couple little facts about space and the evening sky that you might not have considered before, or maybe it's just a little bit of a refresher. I don't know. But if you have any ideas, thoughts, questions, drop us a comment, send us an email if you'd like. You can go to our website. It's nightsky.io. I'm sure you can find out some information there about how to contact us. If you'd like to rate, review, and subscribe to this podcast, that would change our world. Maybe a little bit. It's just a little podcast. You can subscribe, though. It'd be sweet. And a couple comments or a rating would be fun to have, too. So if anybody out there is willing to do it, we've got a couple comments before. That was fun.
It's pretty fun.
Yeah. It's cool
I appreciate
finding out that anybody actually, is able to listen to some of the fun stuff that we get to talk about for space and astronomy in the night sky above us. So it's cool. But on behalf of Marina Hansen, my name is Billy Newman, and I want to say thank you very much for listening to this episode of the Night Sky Podcast.